Suppose you were given this crazy problem. Factor 2 to the 18 plus 1. With 2 to the 18 minus 1, we can visualize it as the difference squared, but it's plus 1. So you try to think a little bit. What if you have 2 to the 9th plus 1 and you square it? That's going to give you 2 to the 9th squared, which is 2 to the 18, and it's also going to give you 1 squared, which is 1. But it's also going to give you 2 times this times that. And personally, I don't bother denoting and multiplying by 1. So what we have is 2 to the 9th plus 1 squared is equal to this, which is 2 to the 18, plus this, which is 2 to the 10th, plus 1 squared, or 1. So we have on the right side the pieces that we do want, namely 2 to the 18 plus 1. But we have more than that. Well, let's get rid of the more. Let's take away 2 to the 10th from both sides. The left side is 2 to the 9th plus 1, quantity squared, minus 2 to the 10th. And this is equal to what we want, 2 to the 18 plus 1. At least now we have our subtraction. Now, what you need to realize is that 2 to the 10th is 2 to the 5th squared. So now I have something squared minus something else squared. And when you have x squared minus y squared, x and y are being squared, write it down twice in brackets. One gets a plus, one gets a minus. So we have 2 to the 9th plus 1 and 2 to the 10th. 2 to the 5th is what's being squared. And 2 to the 9th plus 1 and 2 to the 5th. One gets a plus, one gets a minus. And this still equals to what we want to factor. Well, at least now we have two factors. Now, for the record, at the very beginning, you could have multiplied 2 by itself 18 times and then added 1 and try to factor from there. Now we just have 2 to the 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. We also need 2 to the 5th. So it's 2, 4, 8, 16, 32, 64, 128, 256, 512. 2 to the 9th is 512. Okay, so now we have 512 plus 1 plus 32 times 512 plus 1 minus 32. And that turns out to be 545 times 481. Okay, so we're really getting somewhere. So now we know that 2 to the 18th plus 1 is 545 times 481. Now, clearly, 545 is a multiple of 5. Well, 5 times 100 gives you 500, and to get to 45, you need 9 more. 109 times 481. So, and 109 is prime. Or maybe we'll check that later. Actually, let's check that now. The square root of 109 is less than 11, which is the square root of 121. We only have to check numbers up to 11 to see if they go into 109. And since 109 is an odd number, an even number won't go in, we have to try 3, 5, 7, 9, and that's it. Well, if you add the digits of 109, they add up to 10. So 3 doesn't go into that, nor does 9. And 5 doesn't go into a number that ends in 9. So it's all up to 7. Does 7 go into 109? Well, 7 goes into 10 one time with 3 left over, but 7 doesn't go into 39 evenly. So 109 is not factorable. So for now, we know that our answer is going to be 5 times 109 times, had you factored 481, if in fact it is even factorable. Now, what you should know is that 481 is less than 484. So are their square roots. And the square root of 484 is 22. So we don't have to go beyond 21. Now, since 481 is odd, once again, we'll try the odd numbers up to 21. 11, 13, 15, 17, 19, 21. And we may not even have to try all of them, because we may find factorization earlier on. Well, if you add the digits 4, 8, and 1, that adds up to 13. Well, 3 doesn't go into 13, nor does 9. And 5 doesn't go into 481 because it ends in 1. What about 7? 7 into 481. There's rules for 7 and 11, but personally, I just like to work it out. 7 times 6 is 42 with 6 left over. 7 doesn't go into 61 evenly. What about 11? Does 11 go into 481? Well, 11 times 4 is 44 with 4 left over. 11 doesn't go into 41. So no 11. What about 13? Does 13 go into 481? Well, 13 times 3 is 39. With 9 left over, bring down the 1. 13 goes into 91 exactly 7 times. So 481 is 13 times 37. 13 is prime and 37 is prime. So what we just established is the following. That 2 to the 18 plus 1, when you factor it, these are the 4 factors, the prime factors. 37 is prime, 13 is prime, we verified 109 is prime, and clearly 5 is prime. If you like math like this, please subscribe to my channel, tell your teachers and friends about it, and most of all, have a great day. Thank you.